In this video, we will learn a Monte Carlo simulation using full Monte risk analysis software to assess product uncertainties and risk. Okay, so a Monte Carlo simulation helps product managers to predict possible outcomes and identify risks and make informed decision based on the probability analysis. So before running a Monte Carlo simulation in full Monty software. So we will go to the view. I am just going to share with you the basic settings. Okay, so we will go to the default duration units. You can see here. So so we will choose usually we will choose the day. Okay, if you want simulation, if you want to get the results for weeks, so you can choose the weeks. You can also choose the hours and minutes as well, but I will choose the days. Okay, so the second, you can again go to the view and you can change the date format from here if you need. Okay, so otherwise, no need. Okay, so after that, okay, so on the right side in this window, you can see here we have a normal distribution. Okay, you can change the distribution as well. Even you can change the optimistic, most likely, and pessimistic uh, distribution here. Okay, you can see, but we will run the simulation for the default data. You can see here we have the default data here. Okay, so next what we have to do, we will go to the run analysis, and you can see here we have number of simulations. We have 1000. Okay, so and preferred date, duration, histogram, interval. You can see we have already choose the day, sorry. So we have already choose the day. So if you want to choose the week or hour, so you can choose. Okay, so first, we will run the simulation for the 1000 number. So we can also increase. We can also, let's suppose we want to run simulation for 2000 simulations. Number of 2000 simulations. Number of simulation for 3000, 4000, even 10,000. Okay. Let me clear one thing more here. If you want the results more accurate, so you can increase these a number of simulations. Okay, first we will run the simulation on the default data, default setting. So let's click on OK. So next, let me collapse. Okay, so here you can see here we have here the histogram. So we will click on this option. You can see here, click on this option, and then now you can see here we have the full Monty uh, graphical report here. So now let's discuss about this full Monty graphical report. Let me maximize. Now you can see here the actually actually this graph show us the histogram, that is the visual representation of when your project is expected to finish. Okay, based on the 1000 simulation. Okay, so 1000 simulation, Monte Carlo simulation. Okay, so it helps in predicting the product risk and understanding the likelihood of meeting the deadlines. So first, let's take an the overview of the key information from the report. The top section. I am talking about this top section. Okay, so here you can see the product name. Okay, so number of simulation, you can see we have run number of simulation for 1000. Okay, simulation. So each simulation actually represent a different possible product completion scenario. Okay, so analysis date is here. That is the 22nd Feb 2025. So here you can see we have here mean finish date. That is the, you can say, average finish date. So you can see we have here the October 3rd, 2025 at 5 p.m. So next we have the standard deviation. Standard deviation, you can see we have 7 hours, so it shows the variation in the predicted finish date. Okay, so after that we have a deterministic value, that is the the uh, 3rd October and at 5 p.m. So actually, you can say it's a probability of achieving this date. Means we have 50% chance. So meaning there is the 50% chance of delay beyond this date. Okay. So let me clear about the deterministic value. Actually, you can say it's a believing that everything that happened must happen as it does and could not have happened any other way. Okay, so are relating to this belief. So it would be overly deterministic to say that if the party did not change its leader, so the new one would continue to make the same mistakes. Okay, so this is the example. Just for and this was the example just to understand the deterministic. Okay. Okay, so now let's discuss about these purple bars. Okay, this we have the histogram here. So each bar represents the percentage of the simulation that predict the project will finish on that day. Okay, so the height of each bar show how many simulation predicted are completion on that day. Okay, so the tallest or longest you can see here, the this bar show us the most likely finish date. Okay, so you can see the observation from the histogram, a most likely completion date between the 3rd October and 6th October, uh, according to the tallest bar, okay, or long bar. You can see here. You can see here. Okay. So finish before October 2nd is unlikely. So here you can see there we have the small chance of delay beyond the October 10th October. Okay. Okay. So now you can see we have here the blue bar, that is the cumulative actually. So that is the cumulative, you can say, probability here. Okay, it's going to start from here and it's increasing continuously. Okay, and it is here you can see up to 100. So the blue curve shows the cumulative probability of finishing by a given date. Okay, so it start from the zero, you can see from the 0% from the left side I'm talking about here, from here. Okay, and increase as time goes on. Okay, so it reach uh, up to 100% on October 15. You can see here, this means every single simulation finished by this date. Okay. Okay, so now let me show you on the right side here. You can see here the small bars. Okay, actually, these bars you can say like the here we have the probability of finishing by the specific dates. Okay, now you can see first is we have here the first one is going to 2nd October. Here you can see that 20% chance of completion. Then after that we have 40%. Okay, so uh, on a Friday 3rd October we have chances 40% that it will complete on 3rd October. Then after that we have 60% chance that it will complete on the 6th October. You can see here. Then after that we have the 80% chances that it will be completed on the 7th October, and final you can see we are at 100%, we have chances that it will complete on 15 October. Okay, so let me give you a one example here. If you need a least an 80% confidence level, so you should plan for October 7, 2025. Okay, so if you must finish by October 3rd, 2025, so you can say you have only 40% chances of success. Clear? So actually, here you can see here the each bar represents 1 day. Okay, so markers show the start of the interval. Okay, now if you need a high probability of one-time completion, so schedule you can say your schedule project should be finished by the 7th October instead of 3 October. Okay, you can see. So it's identify tasks with the high uncertainty and take corrective actions. So it consider adding extra resources to speed up work. Okay. So if you must finish by 3rd October, you can see here where we have, so you have the probability of success is only 40%. So you should fast track or crash key activities to improve the schedule confidence. Okay. So then you should identify which task contribute to the most schedule risk. Clear? So if delay are not acceptable, so look for the task with the highest uncertainty and adjust. Okay. So use the contingency buffers for higher risk activities. Then prioritize the critical path task to minimize delay risk. Okay. So the traditional, the traditional MS project completion date without risk analysis October 3rd we have over there. That this means that we have the 50% chance of success. So 80% confidence completion 7th October. That is the you can see the safer deadline. Okay. So 100% confidence completion date that we have the 15 October. So that is the guaranteed finish. Okay. So there are 50% chances of delay by on the October 3rd, 2025. Okay. So this was a simple overview of this graphical report, which is generated by after running the simulation. Okay, Monte Carlo simulation in full Monte software. I hope everything's clear related to the this graphical report. Thank you so much for watching this video. See you in the next video.